Okay, so now we're going to write the equation of a translated ellipse, but instead of giving the equation, we're going to go ahead and work with the description. So we need to pull the pieces apart from what's being described. We have a center at 4, 3, which tells me about the top part. We have a vertical major axis of 10 and a minor axis of 8. So if the major axis's distance is equal to 10, and the minor axis's distance is equal to 8, we know that the center is the middle. So just to draw a generic picture, this would be 4, 3, this point. And we have a vertical major axis, so it would go through this way. We'd have a point here and point here. These would be our vertices, right? This whole distance is 10. And my picture is not the best here. Let me erase that guy. Get it a little bit cleaner. There's where the center is. So that means that each of these pieces are 5 units, because if the center is the middle, and the whole distance of the segment is 10, means each piece is 5 units. So that tells me right away that A is equal to 5. And then we'd do the same with the minor axis. I know B is equal to 4. And so now, using this information, I can go ahead and create the equation, and then I can use that information to graph, and I can actually start graphing with what I have right here. So I know I'm dealing with a vertical major axis, so that means that I'm going to have x squared over b squared plus y squared over a squared is equal to 1. It's a vertical major axis, and that's where a is underneath y. I know the shift for the x is 4, and the shift for the y is 3. Always equal to 1. If a is 5, that means I'm going to put 25 underneath, and b is 4. I'm going to put 16 underneath here. And so here's my equation. And now I can go ahead and graph it. The one only little piece of information that I need for the graph is the focal points. So I'm going to write down what I have. I know that a is equal to 5, b is equal to 4. I don't know what c is, and the center is at 4, 3. I can use a squared minus b squared equals to c squared to find my my focal point. So 25 minus 16 is equal to c squared. C squared is equal to 9, so c is equal to 3. And so remember, all these points, I'm going to shift 5 units up and down from the center. So a lot of times the easiest thing to do, I'm going to go ahead and zoom in on this. The easiest thing to do is to plot the center first. So that's at 4, 3. And then I know it's a vertical major axis, so I'm going to go up 5 units. So if this is 4, 3, if I'm going up, I'm adding 5 units to my y, so that's going to be at 8. So we're at 3, 4, 5, 6, 7, 8. And then I know I'm going to go down 5 units from the y to get that. So that would be at -2. So my point for my vertex at the very top is going to be 4, 8. And the one at the very bottom is going to be 4, -2. I'm just going straight up and down. Okay, so I got that one taken care of. Now I'm going to go ahead and plot the co-vertices. So I'm going to go this way. I'm going to subtract 4. So if I subtract 4, it's already at 4, so I'm going to be at 0. When I go this way, I'm going to add 4, so that's going to put me at 8. So 1, 2, 3, 4, 5. 1, 2, 3, 4. Having trouble counting today. So this point is going to be 8, 3, and this point is going to be 0, 3. Now I need to plot my focal points, so we'll change that to blue. And we know that C is 3, so I'm just going to go up 3, 1, 2, 3, and down 3, 1, 2, 3. And those are my focal points. And I'm going to go ahead and draw my shape. And connect the outside dots here. And we have an ellipse. not the best drawing there, but we have an ellipse that's longer vertically than it is horizontally, and that's how we can use the description to come up with our equation. Oop, sorry about that, didn't mean to change how it looked on the graph. And we need to make sure that when we plot our vertices, co-vertices, and focal points, we're always shifting from the center. Not 0, 0, we're shifting from the center of the shape.